In this question, we will try to identify the correct temperature time graph in which we are said that the water at room temperature is placed in a freezer. So what will happen when you will keep the water in the freezer? The temperature of the water will drop because the heat of the water will be thrown out into the surrounding. Okay, important point is which they mention information or data that the specific heat capacity of water is 2 times more than specific heat capacity of ice. So now what is conceptually it means? Specific heat capacity is the certain amount, a specific amount of heat required to raise the temperature or to drop the temperature of a substance of 1 kg of substance by how many degrees? By 1 degree Celsius or by 1 Kelvin. For instance, the water requires 4186 joule per kg per Kelvin or per degree Celsius. This is a specific heat capacity of the water. Okay, the second very important point which is mentioned over here, that the thermal energy is transferred from the water at a constant rate. It means, dear students, it means that the power is constant. Okay, so if the power is constant, which means that the power is equals to the rate at which thermal energy is get out of the water, delta T. Okay, so it's delta Q over delta T. This is a rate at which the thermal energy is drawn from the substance. This is the power, and according to the question, it is constant. So if we further open this, because the thermal energy is mc delta T when the temperature is changing is equals to constant. Okay, and mc, and I'm taking it in a one bracket because it has a significant role in its answer, in its solution. So students, you see that this is the gradient or the slope of graph. So gradient of graph. Now if I take mc on the other side, so we can see, and can we turn this thing in proportionality, then we see that the slope of the graph is inversely proportional to the specific heat capacity because the mass is also constant. So now, so don't you think that when we say the specific heat capacity of water is 2 times of specific heat capacity of ice, right? It means that if this is more than Ci, it means that the slope or the gradient should be less than. Okay, so it means that in the graph, when you will see that the portion, the segment of the graph in which water is converting, or for let's see here in this diagram, this is the time during which water is existing, right? So which means that it should be less steep. All right, it should be less steep, and less steep is in which segment? This is only in the option B and in option A, because the C and D shows the more steep graphs, right, in the beginning, in the initial phase. So that's why D and C are not possible. And in fact, A is also not possible because both will not, it is not possible that the both will take same time. Okay students, so TW cannot be equals to T ice. Okay, they cannot be equal because their specific capacities are not equal. So A is also ruled out. So right answer is only B. And you can also see that the segment of the graph in which the, because this is a point where water is completely converted into now ice. So after that, temperature is further dropping. So you see that its slope is more than its slope. So the right answer can only be option B.